Welcome back to the OPEX podcast. On today's episode, I am joined by Dr. Jon Johnston from the University of Surrey in the UK. Jon is a world-renowned expert and researcher in the field of chrono-nutrition. So on this episode, Jon and I discuss everything and anything to do with that topic, chrono-nutrition. Guys, this was a fascinating discussion with Jon, and I hope you really enjoyed it. Jon, we are recording. Thank you so much for making time to speak with me today. I really, really appreciate it. I can only imagine that you have a very busy schedule, so I really do appreciate it. But for the listeners who don't know who you are, fill us in your background.
Okay, so I'm Jon Johnston. I'm from the University of Surrey, and I study circadian rhythms within humans. And I'm particularly interested in how human metabolism and nutritional effects relate to our circadian system. So in terms of my background, I started off wanting to be someone who studies drug action within the brain. And then I started a PhD studying how brains control the hormonal system. And that was in the context of seasonal biology. So for example, how things like hamsters and sheep change their reproductive system and all this kind of stuff between summer and winter. And that, it turns out, involves our daily circadian clock. So our clock can actually measure seasonal time as well as daily time. And from that, when I started my own research group down at Surrey, I needed to find something a bit different. It was a time when the links between clocks and metabolism was becoming a real big thing.
Just from looking back at a few of your publications, like I saw one from like 2005. So like you've been doing this research for a long time. So like how did you get into circadian biology? Because like it's only now that it's becoming like more of a mainstream thing among like health practitioners and even some performance coaches like myself, like the awareness of how important, circadian rhythms are and circadian biology, light dark cycles, meal timings. I mean, how did you get into it like such a long time ago?
Well, my PhD started back in the late 90s. So I was kind of learning about the whole field of body clocks and rhythms back 20 odd years ago. And it's kind of developed from that, really. And people have always known about the importance, certainly people within the circadian rhythm fields. But I think you made a good point there. It's only quite recently that it's become more mainstream and people working in more traditional areas, metabolism, cardiovascular health, muscle metabolism, have actually started to recognize how important circadian rhythms are to pretty much every aspect of how our body works. And you can see that now. I mean, I've been invited quite a lot over the past few years to nutrition conferences, to obesity conferences, diabetes conferences. And it's now pretty common if you go to any kind of major conference, some kind of session there on body clocks and rhythms, because it might not be the main driver of how every part of our body works, but it certainly influences pretty much every single thing that happens.
What I'm intrigued with currently at the moment, as we just talked about while we're offline, is the regulation of these peripheral clocks and, certain things like meal timing and how important meal timing is in the regulation of these peripheral clocks. So for the listeners, when we say peripheral clocks, we're talking about the regulation of the clocks in peripheral tissues of our body, like our liver and our pancreas, skeletal muscle, GI system. And Jon, I mean, you obviously are well more versed in this than me, so you can expand on this. But can you maybe just get into your research on meal timing, the peripheral clocks? This whole concept of chronobiology, chrono-nutrition. So I'm fascinated with this. So I'd love to just hear your whole background on that.
Okay, so when I started my group at Surrey, one thing that I found particularly interesting and was an area that needed to be researched a lot more was how these so-called peripheral clocks work within humans. So just to explain again what peripheral clocks are, people sometimes refer to the clock in an individual. In actual fact, there are billions of clocks. Almost every cell within our body has its own clock. So they're linked together as a complex system. And as you said, there's a part of the brain called the SCN, which is referred to sometimes as the central or the master clock. And that's the one that has a direct input from your retina. So it synchronizes to the light cycle out in the outside world. But then every other clock in every other part of the body is termed a peripheral clock. So any clock outside of the SCN is basically and as you say, they've been particularly well studied in metabolic tissues, such as skeletal muscle, such as adipose tissue or fat, such as the liver, such as the pancreas that makes hormones like insulin. So we're starting to learn a lot more about how these different clocks in different parts of the body work. However, most of our information about peripheral clocks comes from animal studies, because obviously from a practical point of view and also from an ethical point of view, you have to be a little bit careful cutting bits of tissue out of your human volunteers, because ultimately you want them to be able to walk out of the lab afterwards and get on with their lives. So most work that's been done studying humans has involved analyzing blood. And in blood, you can measure hormones like the hormone melatonin. You can measure metabolic hormones such as insulin. Measure metabolites like glucose and different sorts of fat molecule. But of course, that's not directly telling you what clock in a particular tissue is doing. So one of the first things I wanted to do was to find out how we can study certain peripheral clocks in humans. And so working with clinical colleagues, we started a protocol where we could actually take multiple biopsies of fat, subcutaneous fat from our volunteers, which means that from any one person, you can get lots of different biopsies taken across a day where you have your participants, your patients in control conditions. So you can actually look at a molecular level, at a genetic level, what is happening within peripheral tissues within humans. And very recently, we've even done that and expanded it to skeletal muscle as well, working in big international collaboration. So we now have a pretty good idea that these clocks and what they're doing in humans match pretty well with what people have previously found in animals. But of course, we're still very limited in terms of what kind of tissue we can take from our volunteers. We can take subcutaneous fat that lives just under the skin. We can take skeletal muscle if we're careful, but we can't do things like take liver or pancreas tissues. Clearly, that's far too invasive. So it's a good example of how animal experiments, and I know there are a lot of people out there who are less keen on it than others, but for certain things, we are very reliant on animal experiments to tell us how basic processes work, simply because we cannot do that kind of experiment in a human being. So it's a combination of the human work and the animal work that together is building up this picture. And
no, go ahead.
Okay, so I was just going to say, in terms of metabolism, how do people know about clocks and metabolism? Well, it was the first kind of cues were when people about 15 or so years ago started to study every single gene that was rhythmic in a particular tissue. So you can do techniques which will measure thousands and thousands of genes and proteins in a sample. And what they found was that in any tissue, such as the liver, at least 10%, so 1 in 10 of every single gene within a tissue is actually going up and down over the course of the day. And when you then have a look and see, well, what is the known function of these genes? In all cases, metabolism is one of the key processes. And then people have more recently used genetic approaches to actually stop the clock, but only in one part of the body. So you can stop the clock in just the liver, or just the pancreas, or just the muscle. And when you stop the clock in one of these tissues, leaving the rest of the body completely normal, you see massive changes in how the whole body's metabolism works. So these clocks exist in these particular tissues around the body, and each clock in each tissue is individually really important for how our whole body metabolism works in a normal, healthy way.
How do these peripheral clocks exactly work in coordination with the master clock? Because again, I know the SCM is mainly regulated by the light and dark cycles, these peripheral clocks, are they still stimulated in terms of their regulation by light and dark, as well as other external factors like meal timing?
In most cases, or probably all cases, they don't have any direct regulation by light, because light only comes through the eyes and it basically goes through the SCN clock.
But John, can't your skin not pick up light?
Not in this way. There was a story about 20 or so years ago that there were photoreceptors, so light-sensitive molecules circulating, and that if you shine a bright light behind someone's knee, that can affect their
melatonin
system. That's complete rubbish.
Yeah, I was wondering.
It's been shown by about a dozen or so groups tried to repeat it, and every single one found it was absolute rubbish. And apparently, when people, I perhaps should be a little bit careful about talking about my colleagues, but when apparently people spoke to them at meetings, they found out that the way they did their experiment was completely uncontrolled, and these people were able to actually, for example, watch telly, and they knew exactly what the time was just from being aware of their surroundings and being aware of what the clock time was. So it wasn't, should we say, the best controlled experiment, I don't think.
So what is, and if there is, what is the relationship between the master clock and these peripheral clocks?
Okay, so people often use an analogy of the SCN clock being like the conductor of an orchestra.
Yeah.
And so the way that works is that all of your peripheral clocks will happily exist. If you take a bit of your liver or a bit of your muscle and you put it in a dish, you still have a clock in each cell, and that will happily tick away. So they are autonomous clocks.
Okay.
However, if you go back to this analogy of an orchestra, in an orchestra you've got a big group of musicians, each of which can play their piece of music perfectly well. But for the whole orchestra to work properly, every musician has to be in time with one another. If you get the kind of brass section starting before the string section, you're just going to get a horrible discordant mess. So that's why you need a conductor to keep everyone in time with each other. And so the SCN in this analogy is the conductor, and it can work through nerve output pathways. It can work by controlling hormones. Work by controlling aspects of our sleep-wake and aspects of our feeding-fasting cycles.
Right.
Through these methods, the SCN in a normal, healthy person keep all of your peripheral clocks in time with one another.
So, in your opinion, how detrimental is shift work to the regulation of, obviously, not only the master clock, but these peripheral clocks? And probably since Edison invented the light bulb, like how devastating has that been to the regulation of the human circadian rhythm?
I think the bottom line is both of these have pretty profound effects. We know that shift workers have a much higher incidence of all sorts of diseases, metabolic disease, cardiovascular disease, some cancers as well. We can't say exactly for sure how that works, but it's very likely that a big cause of that is that these people are over a long period of time working out of sync with the outside world, but also out of sync with the rest of their body.
Yeah. Like all those studies, they're epidemiological, but they're massive though. Like it's a very big database to support the hypothesis.
Yes, and it's technically very difficult to study shift workers in their normal environment. So although it's possible, and some of my colleagues here at Surrey and elsewhere do study shift workers and have studied them in the past, it's not something that's easy to do. What we can do are experiments where we kind of mimic shift work or jet lag in a laboratory. We can do that, and we can show you exactly how that will affect the body. And there are lots of good papers that have been published on that. But when people, for example, have studied shift work in the past, they find that most shift workers never fully resynchronized their work schedule.
Wow.
And so if like these people are in a sort of constant jet lag situation, they never quite catch up.
Social jet lag, isn't it, as Till called it?
Yeah, I mean, social jet lag is kind of related to all that. This idea that sometimes the of your week or your month, you're kind of catching up on sleep. Other times, you're the opposite way around. But shift work is probably worse than that for the people that have to actually go through it. But there are other things about shift work as well. I mean, you're interested in nutrition. Of course, most people working night shifts, if they work in a big factory, it's unlikely that there's going to be a canteen open for them. And when nutritionists have studied the dietary patterns of shift workers, they tend to find that they undergo a sort of grazing feeding pattern where they kind of are constantly just nibbling on snacks and chocolate bars, perhaps because they're tired and it's a kind of comfort food. Perhaps it's also partly because they don't have access to proper set meals. So it's a very complicated situation, but it's not good for your health. And one of the things that all of us in the field are ultimately trying to work towards is find ways in which we can help shift workers and people who undergo regular jet lag actually improve their health and improve their performance as well, because that will benefit all of society.
So let's get into discussion around the importance of mealtime, because I've spoken to Greg Potter on my own podcast previously, and I recently just completed I'm currently doing a master's. Actually, it's a master's in strength and conditioning, and it's through St. Mary's Twickenham. But one of the assignments was to make a website and put up 4 articles, and 2 of the articles had to be academic topics and 2 had to be opinion pieces. And one of the academic articles I decided to write on was circadian disruption and its relationship with obesity and type 2 diabetes. And a big part of the research I came across was this concept of the timing of people's caloric intake. And a recent study came out where it was 2 groups of females, apparently isocaloric. When you hear the word isocaloric, you're like, nothing's really isocaloric. But when you're comparing people, because they metabolize things so differently. But essentially, one group took the majority of their calories in the earlier part of the day, the more active phase of their day. So the light cycle rather than towards the evening and getting into more dark cycles. And the other group, the opposite, they took most of their calories in towards the end of the day. And essentially after, I'm not 100% sure how long the study was, maybe 12 weeks, was it? I'm not 100% sure. But essentially the group that took in the majority of their calories during the early part of the day had a better body composition and fat loss at the end of the study. And the rationale was that the metabolic machinery of a human being is more set up to metabolize and utilize nutrients when it's getting light, when it's in the daylight, in the active phase, rather than at nighttime when we're getting closer to bed, when really our metabolic machinery should be fasting and allowing the body to actually repair and heal itself. Because the concept was, if you go to bed with a belly full of food, like your gut isn't getting a chance to heal, and your body wants to expend actually that energy on like other cellular healing processes and other things it wants to heal from all the catabolic damage throughout the day. So I'm very long-winded here, I know. But what sort of research have you seen, have you done, or thoughts do you have around this whole concept on not only what we eat, but when we eat it?
Okay, so this concept is sometimes referred to now as chrono-nutrition. So the interaction between nutrition, obviously, and the time at which you eat it or drink it, perhaps. There are lots of different kind of types of study that go into this chrono-nutrition. The one that you just mentioned is probably the one that's been around the longest, at least in human studies. And there are quite a few papers now that suggest that if you have 2 groups of people, as you say, that have the same number of calories every 24 hours, but have a higher proportion earlier in the day, earlier in their circadian phase, then they will tend to have a more healthy metabolism. Some people have reported increased insulin sensitivity. Others have reported more efficient weight loss if you're on a weight loss diet, and it becomes more easy to actually maintain that weight loss. So this idea of kind of morning versus evening energy balance is one now which has a lot of traction. And actually, at the moment, myself and colleagues at the University of Aberdeen are actually collaborating on a study to try and work out why that is. I think it's pretty clear now that if you have a high proportion of calories in the morning, it's going to be good for you metabolically. We don't yet know the mechanisms. We don't know why. And that's what we're addressing. So we're looking at daily rhythms of different forms of metabolic energy regulation, seeing how they are affected by when you consume food. So we don't yet know. We've got ideas. Might be, for example, down to the way in which you use energy to process a meal, so-called thermic effect of foods. And that's one of the hypotheses that we're testing, but we don't quite yet have the data. So hopefully 12 months or so, if we end up chatting again, I can hopefully give you the answer to that. But at the moment, we don't know. Simple as that. But you're right. The general kind of one way of thinking about this is that during the day, your clock system is expecting you to be awake. It's expecting you to be eating meals. Therefore, it kind of makes sense that it's more efficient at processing a meal. Whereas during the nighttime, your body is expecting you to be asleep. It's expecting you to be fasting, and therefore it's actually geared up towards slow, steady release from your energy stores to maintain a constant blood sugar throughout the night, to keep everything working properly. Yeah. So intuitively, it makes sense that you process food more efficiently during the day than at the night. But as I say, we don't yet quite know how.
John, is that just during like when we say during the day? Because currently, like you're in the UK and I'm in Ireland, and like I mean, our days last until 10:30 at night now here currently at the moment. So are we just saying that like the body's set up to consume calories when it's light outside rather than when it's dark? Because the concept I've heard of other people is that, you know, so basically if you're from like, let's just say like a northern part of the world, like so Ireland and England, like where we're from, that basically in the summertime we're set up to eat more calories because there's longer light cycles. There was generally more food availability. If we're just looking at this through a purely evolutionary lens, this would have been the time of year where we would have, you know, like there would be more sexual activity. People would have got pregnant. We would have been putting on a little bit of weight because of the extra calories that were available during lighter long cycles with maybe some fruits and berries and apples and whatever, vegetables and whatever was around. And then when it got more towards the winter time, like we've got really long dark cycles then. So we would have stopped eating at around maybe 4 p.m. maybe because the dark cycle was so long. And we probably would have had more prolonged periods of fast. And basically we just would have like killed some animals, had a more higher protein fat intake maybe during the winter, whereas there might be more carbohydrate availability through fruits maybe in the summer and when the light cycles were longer. And basically we just fucking, during the winter, we just held on until it came around to the spring again, and then the cycle repeated itself. So like when we say eating towards the light cycle, I mean, does it just mean that like you can eat as long as it's ideally we're saying you should eat when it's bright and then just don't eat when it's dark if we're just talking about like the timing of meals and this trying to optimize, you know, your like chrono-nutrition?
Yeah, that's a good question that I probably oversimplified a little bit. When I say in the light, I'm basically meaning around the biological morning and early afternoon.
Okay.
Once you get sort of to late afternoon, you tend to lose some of your insulin sensitivity.
Yeah.
And you start to be less efficient at processing. So when I'm saying eating during the day, it's really your kind of breakfast, lunch, possibly and a kind of early dinner. But it's morning, afternoon. You want to try and avoid eating too much late in the evening.
Okay. So my next question to you then is, what about some confounding factors into that? So what if you fasted for most of the day and so a lot of people will do this thing where they back end their calories towards more the evening meal. So, because a kind of very popular thing that's happening lately, John, is like, so there's a lot of people who will intermittent fast will say, okay, and usually the common window that people are kind of using is like 10 p.m. to 6 or 12 p.m. to 8 p.m. And the reason it's more of a social thing, because like most people have dinner at like, 7, 8. Then if you go to Greece or Italy, I remember living with a guy from Italy, and he'd be having his dinner like 9:30. He'd be there sticking on his pasta, like, and I'd be going to bed. He'd be like, "Hey, dinner time," and I'd be like, "What? It's fucking almost 10 o'clock, man." And but like a lot of them countries, because they don't really eat during the day, like, and their whole thing is it's a whole social thing. They sit down with the family. So a few things there on that. What if you haven't eaten basically, or let's say you've intermittent fasted, like it does, like surely that will change insulin sensitivity to a degree. And another big confounding factor is exercise. So I mean, like, what if you have to perform in the evening time, because that's the other thing too. A lot of training sessions with amateur-based teams are usually in 7 p.m. in the evening times. And obviously then there's an insulin sensitization, an insulin sensitivity, that's a better thing to say, an insulin sensitivity effect from that could potentially maybe offset some of the detriments of having, some nutrients at a later time in the day. And one final thing too is that I definitely know shift work too is definitely detrimental. But is there a difference too between having meals at 7, 8 p.m. being detrimental than someone who's eaten during 1, 2, 3, 4, 5 in the morning on a shift? So to me, they're different things. You know what I mean? The body's just not designed to be eating food at 2, 3, 4, 5 a.m. in the morning. You should be asleep at them. But a lot of people are saying that, it's not great to be eating meals even at 7, 8, 9 p.m., going close towards bedtime. But I'm wondering how detrimental is that in comparison to eating shift work? But anyway, that's a different question. The question I'm asking here now is confounding factors. What if you fasted all day and your main meal is at night? And then what if you've exercised going into that main meal at night as well? They're kind of the two questions.
Yeah, okay. So the fasting bit is, again, really topical, and it's possibly, at least from the circadian biology point of view, slightly newer than the morning-evening type of chrono-nutrition. So I must admit, I haven't read much about the intermittent fasting, although I'm aware of it. One form of intermittent fasting that I know more about is called time-restricted eating or time-restricted feeding.
Yeah.
And it's quite similar in concept. The basic concept there is that you reduce the time between your first and last calorie intake of the day. So therefore, you have a shorter eating window, and you have a longer daily fasting period. And there's a lot of work, again, done in animals. And all sorts of different species, not just mice, but also things like fruit flies and all sorts of things. And all of these studies show that, again, there are important metabolic effects and benefits of this time-restricted feeding.
Okay.
Now, is that something to do with the circadian biology of how you process foods? Is it down to simply having a longer daily fasting period? Is it a combination of both? I would guess probably a combination of both, but I don't think we yet know.
Yeah.
In terms of translating the animal work into humans, again, it's something that we've got ongoing at the moment. We've got a couple of recently started PhD projects, and I know people around the world are also doing these sorts of studies now in humans. So in a couple of years' time, we'll know an awful lot more. But the preliminary data that we and a few other groups have published suggest that, yeah, if you do time-restricted feeding in humans, you will get some metabolic benefits. But they've all been quite small studies, what you might call a kind of pilot study, where you test the water to see if something looks encouraging and to work out what kind of effects you might be going to get. Now that we know that, we're all doing much bigger studies to try and actually work it out in a much more rigorous way. So in terms of your question about, well, what happens if you, for example, start eating at midday and finish at 8 or 9 p.m.?
Yeah, say your window starts at 12 and it finishes at 8. So you're doing 16 hours of your fast. So you're fasting from 8 p.m. till 12 p.m. the following day, and then you're eating windows from 12 to 8. So we're saying maybe your dinner is at 8. And from this, sorry to interrupt you, by the way, I'm terrible at that. But it's just so I can give more, so maybe more of a frame of reference, so you can give a better answer. Not saying that your answers so far have not been tremendous; they have, but so let's say if we're saying that, ideally you probably want your last meal maybe to be, at 6 p.m. if you're going to bed at 9 or 10. We'll just say that. But let's say this in this eating window, you've pushed a little more towards the evening. And so far from our conversation, most of the research have looked like most people are saying it's better to get, again, the majority of calories towards the earlier part of the day, the afternoon and the earlier evening rather than later evening. But let's say that your fast is going into that later evening. What is there much of a difference? Is there much of a detriment? Just your thoughts on that.
Bottom line is we don't know. One of the things that we're testing in our current work is to see if you have people with an identical restricted feeding window does it matter where in the day that window lies?
Yeah,
So
yeah.
if you
Very
have
good.
your 8 hours of feeding between 6 a.m.,
And
starting at
2
6
p.m.
a.m., for example, or starting at 2 p.m.,
Very good.
does that make any difference? My guess would be that if you have your short feeding window towards the start of the day, so your kind of breakfast into early afternoon period, you would see a bigger effect than if you
Okay.
have the same length window but starting at 12 and going to 8 or 9, for
Yeah.
example.
Yeah, that seems to be the hypothesis that I've been hearing from other people too. But then the next question, and I kind of asked it, a few moments ago, will be then what about certain transient factors that could influence the metabolic response then to food at different times of the day? So again, what if, let's say you had a group that, okay, their fast was from 6 a.m. to 2 p.m., but they didn't exercise, whereas the group that went from 12 to 8 or 2 to 10 is a bit of an odd window, but say 12 to 8, but they had exercise there, they strength trained, they had a good amount of fat-free mass, so they had a lot of skeletal muscle, so they, from a metabolic standpoint, were very healthy. You wonder then, would there be a difference, So just they're interesting questions that I kind of have, like, so like the transient effect maybe of exercise, could it potentially, set the metabolic machinery up that it wouldn't be as detrimental having your window later in the day versus earlier in the day?
I think, again, that's a really interesting question, but unfortunately, yet again, I don't think we know the answer.
No, it's good. It's good.
People are starting to get very interested now in terms of muscle physiology.
Yeah.
So there's a big metabolic group in Maastricht in the Netherlands, and quite a few of them. These are kind of real big guys in the exercise physiology world, and quite a few of them are now getting very interested in circadian rhythms. The group I know in Bath, and we've been working together looking at rhythms in human muscle, taking again these biopsies across the day, and we're actively looking to answer these sorts of questions. Basically, is there a good time or a better time of day for exercise in terms of the metabolic benefits? It's possible that exercise may be a factor in terms of actually synchronizing some clocks in different parts of your body. These are all interesting questions that I think, I would be very surprised if there weren't a lot of people around the world thinking about them and doing the experiments. Well, as soon as I can get the funding, of course, to do it, because it's not cheap. But it's stuff that a lot of people are thinking about. There are lots of little satellite meetings now about exercise and rhythms, just as there are about metabolism.
Yeah.
So it's basically, it's happening or it's about to happen. But I honestly, hand on heart, don't think we can say for sure at this moment.
Great stuff. No, I really appreciate the honesty. Where do you see this going in the future? So the next question I'd love you to dive into is chronotypes, as in individual people having different chronotypes. Do you believe that? Because I've spoken to so many people where some people are like 100% there's chronotypes, don't care what anyone says, and I speak to other people and I go, it's bullshit. There isn't really. It's like people saying there's L's and Larks. It's like there really isn't a difference. Like some people are real nasty about it, and other people are like telling me there is, and kind of the majority of people I speak that they're like there is, but it's not like this huge, like there's like a massive hours and hours of difference between the different chronotypes. It's kind of like you have your earlies, you have your lates, and you have your in-betweenies. So what are your thoughts on chronotypes?
I think without doubt there are chronotypes. There are people who are more effective at certain times of the day, and that is entirely in keeping with basic theory of circadian rhythms, and it's entirely in keeping with a huge amount of data being collected all around the world. Like with any kind of variation in any kind of biological system, you're going to find that the vast majority of individuals lie somewhere in the middle. And the further you go away from the middle, the fewer individuals you get. So you get a relatively small number of extreme people. And there are well-known kind of diagnostic cases of advanced and delayed sleep phase syndrome. And these are people who are hours and hours out of the norm. So they might, for example, delayed sleep phase syndrome, they might go to bed and go to sleep at sort of 4 or 5 in the morning. So almost when some people are starting to get up, or most people are starting to get up.
And is that just a genetic defect, John?
It has been shown that we know that circadian clocks are controlled by a set of genes and proteins that interact, so that within an individual cell, that cell can measure 24-hour time. And there have been a few studies now that have shown through human genetics that certain forms of some of these genes and proteins are actually the cause of certain types of the advanced or delayed sleep phase and chronotypes. So in some cases, yeah, people have shown that there are genetic pedigrees that are responsible for this. That obviously is going to be a relatively small number of extremes, but even within the norms, there is a wide range of difference. And the idea of chronotype is yet another one where people are starting to get more interested. Most of the human studies that we do at the moment, because we want to keep it as controlled as possible, one of the strategies is to try and exclude people who are extreme in one way or the other. So we don't just take anyone off the streets. We have to very carefully pick who we want so that everyone is kind of normal, in inverted commas, because it's very difficult if you've got a kind of noisy, big mess of different people to start with. It's very difficult to actually then see a response. But now we know what things are causing responses. I think one of the another big question is to find out how do these responses vary between early and late people, extreme morning and evening. And there's actually some work that's been submitted for publication, I know, from a collaborator, where they've started to look at this. It also touches on something that, again, you mentioned before, which is the idea of social life. And when we did our little pilot study on time-restricted feeding, because it was a small pilot study just to work out whether we could do this properly in a bigger study, we made sure that we asked everyone questions about how they felt about this. And what we did in our study is we asked everyone to try and delay their breakfast by an hour and a half, bring their dinner forwards by an hour and a half. So we kind of symmetrically squashed their eating time.
Yeah.
Most people found it okay to delay their breakfast, but you found that a lot of people found it very difficult to move their dinner because it's very social. Some people found it difficult. Some people actually found it quite easy. And one fact that's likely to be involved here is if you have kids, how old are your kids? So if you've got young kids, then bringing your dinner earlier is actually likely to mean that you are starting to eat about the same time as your kids. So it actually becomes more social, more of a family event, and therefore relatively easy to do. If you haven't got young kids, you've got old kids, or you don't have kids at all, then making your dinner earlier means that you're suddenly eating away from your kind of social or family group. Therefore becomes really difficult. And if people kind of go out and have some kind of club or society, whether it's sports or whatever kind of community event, and if that is tied to a meal, then of course it then becomes even more difficult for those people to change how they eat. If it suddenly means they're going out with a group of friends and can't have a curry or a beer because they ate 2 hours ago, they're just basically sitting there miserably by themselves while all their mates are chowing down on their food. So I think social context is really important. Scientists can do lots of experiments in controlled conditions and say, if you do this, it will have this effect on you. But if people can't tailor that to their real lives, you could argue, well, what's the point? In terms of academically, it's interesting, but in terms of making a change to society, it's difficult. So we need to be very mindful of people, their social context, when we try and take our basic experiments and translate them to the real world. But a lot of the colleagues that I talk to at meetings are extremely conscious of this. So it's something that I hope won't be a stumbling point in terms of taking Chrono-Nutrition and applying it to help people in their real lives.
That's great. That's great. It's great to hear you say that too, because I think the sort of perception a lot of people get from researchers is that, like, you know, they're just in these like really sanitized, you know, laboratory conditions, and like how applicable are some of their findings to the real world. So it's great to know that that's in the back of your mind too when you're looking to do your research, or when you're reading other people's research too. Drugs, John. I know. So the next question I have for you is about drugs. Now, being serious, Going forward in the future, because again, one of the concepts about chrono-nutrition was, okay, so we've spoke about the importance of, when we eat, but then when it comes to like medicine, and food itself is medicine, as we know, but in the research they were saying like this concept of chrono-nutrition and individual chronotypes are going to be very important features for the administration of certain medicines and medications and medical interventions going forward into the future. So what are your thoughts on that?
I think that's something which people in the clock circadian rhythms field have been aware of for probably decades now. And there's been a lot of work done on, say, cancer chemotherapy.
Yeah,
Um,
yeah.
and this for fairly obvious reasons. And there are studies going back quite a few decades now to suggest that if, for example, you have two different anti-cancer drugs, if you take drug A in the morning, drug B in the evening, just switch over, you can have a big effect on either how effective they are, but just as importantly, what the side effect profile is.
Amazing.
A lot of cancer patients will voluntarily stop their medication because the side effects are so horrendous.
Yeah.
So anything which helps either the drug to be more effective or for the side effects, particularly for things like cancer drugs, to be reduced, is of course a massive thing. And there's a lot of really good, clear science now that shows that there's a huge potential here. The big problem is it's trying to fit the kind of scientific principles around the daily work schedule of the clinicians.
Yeah.
So we all know that hospital staff are extremely busy and in many cases overworked. If you then suddenly say to them, well, actually, you can only give this drug to this patient at this time, how on earth are they going to be able to fit that into their clinical schedule? And I think that's really been the main stalling point in terms of translating, again, the science into life. And it's difficult to know how to do that, but there's a big group at Warwick University in England. There's actually a French professor who's moved over there quite recently, and he's been looking at this, studying this for about 40 odd years now. And I say that the science is extremely strong and extremely convincing. It's a case of finding a way to enable clinicians to actually act upon the scientific information. I think that's the big problem. But just more generally, in terms of other medications and when they're taken, some of the researchers who have been studying, for example, thousands of genes that are rhythmic in different parts of the body, one of the things that they've now recently been doing over, say, the past 4 or 5 years is working out classes of drugs that you know are metabolized by certain biological pathways and actually seeing what the rhythmicity of those pathways is. And it's been estimated that a huge number of commonest drugs taken in kind of might refer to as the Western world are likely to be metabolized differently at different times of the day. So in a more general context, something which is likely to be able to benefit pretty much all of us, because we all take medicine at some point in our lives. I think this is something which, again, is starting to get traction. And one day, I think that the hope of many people in my scientific field is that we can have not just a list of drugs for conditions, but also a list of times at which certain drugs are going to work better. It may also be that there are certain drugs that we can take that will actually help us to reset our body clocks. So, for example, we know that there are certain molecules that interact with parts of our cellular clock process. And so it may well be that some of the big drug companies are quite interested now in finding drug molecules that you can actually take that will actually help you to reset your clock to a time zone or perhaps to a new work schedule. And these things, of course, will help us and all the people that are going through jet lag and shift work. But of course, from a drug company's point of view, without wanting to be too cynical about it, this is something which you might need to take pretty much every day for the rest of your life. So potentially for them, it's quite a money spinner as well. If they can show that a particular drug is going to help someone to synchronize their clock system with their health, they're going to be taking a lot of this medicine, which means that they're going to have to be, someone's going to be buying or prescribing a lot of this medicine. So I can see that becoming quite a realistic possible future in terms of circadian rhythms as well. Another thing which we haven't talked about yet is foods. We know that food can reset certain, particularly peripheral clocks in the body. Again, it's mainly animal work, but my group published a couple of years ago, I think it's probably the first really detailed study where we had people on a fixed lighting and sleep schedule, but we just delayed their meals by 5 hours. And we saw, for example, an exact 5-hour change in the way in which their glucose homeostasis, their glucose metabolism is regulated.
Yeah, that paper is free to meal timing regulates the human circadian system. That paper.
Yes, that's right. Yeah.
Current biology report. Yeah, it's open access. I'll put it in the show notes.
Okay, pretty much all of certainly my stuff and most people's stuff is open access.
It's free. Yeah, it's great.
Yeah.
But, sorry, continue. You were just finishing your results from that. Sorry, I interrupted.
Oh yeah. What I was going to say was that it's early days. And as I mentioned before, we're unable to see whether liver clock markers have changed because we can't take liver out of people very easily. But we can show that some human metabolic rhythms are more powerfully reset by food timing than they are, for example, by light timing and by sleep timing. So it's already recommended that people undergoing shift work and jet lag have properly timed light exposure to help them acclimatize. But we can probably now add to that
mealtime.
Also change your meal time as well as the lighting schedule. Then that will actually help you even more to be set to the new time zone.
Well, just going back to drugs potentially resetting certain clock systems in the body, but sure, like where people are already doing that with melatonin, are they not? When people travel, they utilize melatonin to a certain degree to help synchronize the system a bit quicker.
Yeah, a lot of people are taking that. Of course, you can't easily get melatonin in many parts of the world. Certainly,
I can get it for you, John.
Fantastic!
I know a fella who knows a fella. I know John.
But yeah, a lot of people kind of when they go from the States or Canada or somewhere, they just go to a drugstore and stock up on the stuff.
Yeah.
With melatonin, like all of these so-called chrono drugs or chronobiotics, it's when you take it. You've got to take it at the right time for it to be effective. But also, I suppose you also need to think about where melatonin might be acting on the body. There's evidence that melatonin will act on the master clock in the brain, which of course is a really good place for it to act if you want to reset. But is it acting on clocks throughout the entire body, or is it only acting in certain clocks? It may well be that if you have a kind of more basic drug that will act on every cell in the body, then that actually might be more effective than melatonin. But you're right, there are existing things like melatonin and light exposure and sleep training, which can already help you to acclimatize.
John, have you seen much research around melatonin and its relationship with insulin sensitivity? I've read in some papers, that the secretion of melatonin, it's like antagonistic to insulin. So like, at nighttime melatonin is going up and therefore insulin goes down, and then vice versa. Or is it just that that's just like there's no like cause and effect there? It's just purely coincidence. It's just a correlation like that. In the morning time, insulin's higher, melatonin's lower because cortisol is higher. But like I read in some papers that they're because I think maybe they gave subjects melatonin and it decreased insulin sensitivity. Maybe that's why they thought there's like a mechanism there. Do you know anything on that?
Yeah, it's a bit of a thorny issue, if I'm honest.
Okay.
In general, melatonin has been something which circadian biologists have been a little bit cautious about for a number of years, because there's back in the mid-90s, a group of researchers basically made all sorts of claims that melatonin would cure cancer, improve your sex life, make you live to 150, and all sorts of crazy nonsense. So as a result, a lot of clock people over the past 20 years have kind of backed off from melatonin because it became a bit of a kind of dangerous territory.
Yeah.
Wanted to be taken seriously. However, there is a very interesting literature about melatonin signaling, things like obesity and diabetes. one of the problems with that area is that a lot of the work that's, for example, been done in animals, if you're studying a mouse or a rat, these are nocturnal animals.
Yeah.
They're awake during the night. But these animals, like humans, still make melatonin at night. So in something like a mouse or a rat, they are basically secreting melatonin when they are most active and when they are eating. For an animal like a human or a day active animal, they are making melatonin when they are asleep and when they are fasting. So it becomes very difficult to work out because you've got melatonin at the complete opposite time of day. So there is some quite strong evidence in humans that melatonin signaling could be related to insulin sensitivity.
Okay.
So lots of genetic studies came out sort of 10 or 15, or perhaps in the past 10 or 15 years. And they show if you have a particular genetic form of one of the melatonin receptors, you tend to be more or less sensitive to insulin. So I think it's probably fair to say there's something there, but it's difficult to know how it's working and how important it is. Again, because it's quite difficult to do these studies, and because it's quite difficult sometimes to get a license to use melatonin experimentally, it's also a lot of hassle for researchers to actually do those sorts of controlled experiments. So potentially there's something there. I'm not averse to the idea that melatonin is somehow involved in insulin signaling, but how much further the story is going to go anytime soon, I honestly don't know.
I know you touched on this a little bit earlier on, and I asked Greg Potter this too. How much can we take away from rodent models and apply to humans because of them being nocturnal?
Okay, that's a really interesting general question. And again, it's something which is popular in the press in terms of animal research in general. I think in terms of basic mechanisms, we can take an awful lot from animal studies.
Yeah.
Perhaps when we get to the more kind of detailed physiology, we might need to be a little bit more careful about interpreting. But to give you an example, so from the circadian clock field, the Nobel Prize was, of course, awarded very recently to
the three guys.
Yeah, and they got the prize basically for studying clocks in fruit flies or Drosophila. Which is a really well-known genetic model in all sorts of different things. And the clock genes that they and people actually before them discovered, called periods, are genes, proteins which exist basically all the way through to humans. So a lot of the clock genes involved in flies are the same clock genes that humans have. You think fruit fly to human, massive difference, but the genes and the basic concepts, the basic mechanism of how a clock works is almost identical in pretty much every species that we look at.
But sure, we share so much of our DNA with most other species anyway.
Yeah. People don't realize, and I remember being told even at when I was doing my last couple of years at school, sometimes people don't even realize just the structure of our body. So if you take, let's say, a mouse and a human being, and you kind of peer under the skin, we have basically the same organs laid out in the same way. So it's something which sounds obvious to anyone who's a biologist, but if you're not, you never think about that. But actually, the basic way in which our bodies are put together is extremely similar. There are, of course, some differences, but when it comes to working out basic mechanisms of how something works, we are reliant on animal models to tell us that, because we can make genetic variants of animals, so we can find out if we remove one gene, what effect does that have on the body. We can't obviously do that in humans. Hopefully, of course, we never will be able to do anything like that. So I think with most, if not all, forms of biosciences, certainly anything that ultimately wants to improve human health, it's a balance. Every system that you work with, every type of experiment that you do has strengths and it has weaknesses. As long as you recognize both the strengths and the weaknesses, then I think you're in a good position to take the best bits of information and help build it together to form a model of what's going on and how it's happening. So I'm someone who basically only researches human beings, and I do a bit of cell culture work and growing cells in a dish in a lab now. But I'm not one of these people that says everything must be in humans, because to do that we would be vastly limiting our understanding of how this works and potentially inhibiting our ability to help human beings as well. So I'm very much in favour of animal research, as long as it's done properly, and it's done in a way that fills in gaps that we can't fill in by studying people.
Yeah, definitely. Big time. I'm the same too. I'm definitely don't want to come across as someone who like rolls his eyes and says, a rodent model, sure. What can we learn from that? Because again, I appreciate like research is tough, man. You know, getting grants, getting subjects. I mean, again, if we limit ourselves to humans, like we'd be really snookered behind an 8-ball, you know. So, yeah, I mean, it's I guess just it's, you know, the sort of balance view is that like, listen, there's limitations to using animals, but like at the same time, we'd be so far behind if we didn't utilize an animal model too.
Yeah, and a lot of the human research that's done is based upon what people have found out in animals.
Yeah.
You're then able to take into humans, but without that original animal research, we wouldn't be able to do the kind of things that we can do in beings. So, it's all tied together, and I think again, you just got to take a balanced view of this.
So I've only 3 more questions for you, based around our topic today. You know, chrono-nutrition, chronobiology, you know, the circadian circadian regulation, and the factors that go into that. One thing I meant to ask you, just when we were previously talking about like restricted time feeding and sort of the time in the meals, I was having a conversation with a friend of mine, Mark Kilcannon. He's actually the head strength and conditioning coach for the Sydney Swans down in the AFL in Australia, and I was talking about my study and research into circadian biology, and particularly talking about time restricted feeding and this concept of, you know, dispersing your nutrients through at different times of the day, 24 o'clock morning versus evening feeding. And he asked, like, and this question actually came to my mind too, and I meant to ask you earlier on, so I'm going to ask you now. He was like, in his mind, it made no sense that humans should eat the majority of their calories earlier in the day from an evolutionary standpoint, because he was like, surely you hunted all day and you brought the kill home later on in the day and ate it. Now, I know one thing I'll say is I'm not one of these people too who's like I do look at evolution as an aspect to look at things through a certain lens, but I'm definitely not one of these people that's like, well, if it isn't evolution, it can't be right, because that's also a flawed way of thinking too. But it was just one concept that he brought up, and it was been on my mind too, that, you know, would humans not have evolved to be more active and kind of not get as much energy balance through nutrients throughout the day, and kind of, you know, would have ate more of their calories towards the night? Like, would our biology not have been set up towards that over evolution? Like, so it's just a question or a thought, and I'd be interested to hear what you think.
Okay. Well, I mean, there are a couple of things there. I suppose one is, and I'm not an evolutionary biologist, so I'm basically trying to come up with what would seem plausible to me. One thing as well, if people go out hunting, for example, in the morning, who's to say that they're going to eat that hunt, that kill, that harvest the same day? You know, why not? You know, why is it not possible that they could hunt something on one day, and what they've gathered that day will last them for the next week, and they could eat it at any time? But it's also assuming that they are hunting in the morning and not hunting in the evening, collecting something for the next morning. And you know, I have no idea how kind of ancient populations went about their life, but that I'm not sure that would be such a strong argument. Another thing, of course, is that when we're talking about health in modern day society, we're basically talking about effects of bad health, which usually hit us in the middle to late age. And it's only fairly recently that we've had the luxury to be living that long that these sorts of things kick in. If you're living in some society where most people only live to about 40 years old, things like obesity, metabolic syndrome, cardiovascular disease probably weren't. Cancer probably wasn't even a consideration at that point, because they were dying before these things tend to become important. So
manifest.
Again, I'm not speaking with any great authority on this subject, but I think there are various reasons why the argument that you mentioned is necessarily valid.
Yeah, no, it's just, again, it wasn't even an argument, it was just a thought in his mind. But like I said to him too, like kind of similar, I said to him, well, you know, if you kill something that, like, but even let's say if we went right back to paleo times, like if you kill something probably at 11 a.m., you ate it then and there, like, do you know what I mean? Because it was like you had no way of storing it. And I also think too, a lot of people, when they think of hunter-gatherers, they only ever think of them as hunters. It's like they got the majority of their calories in through gathering. So, you know, so they were probably eating a lot. Like some evolutionary biologists said, like they ate a lot throughout the day, like grazing, like, you know what I mean, from all the gathering that they've done in terms of plants and berries and stuff. So there actually was a lot of eating throughout the daytime too, you know. And so I mean, listen, and again, I'm not speaking with any authority either, because it's not my field of expertise. But it was just an interesting question that he came up with. Probably, again, like there's just been certain societies throughout human civilization where, again, it was just more of a social thing that you know, maybe if you looked at like Roman Empire times, and which isn't as far back now as Paleolithic era, but like, you know, they probably would have had their big feast towards the end of the day after a big battle or something like that. And like, again, like we spoke about, it's a lot of social things that drive certain behaviors. So we start to think that, oh, is it not like normal to have all your calories at more towards the evening? It's like, well, it's normal. Like it's common for people to sit down and have a social gathering. But if we're talking about like optimal health, this is what science is telling us in terms of the metabolic machinery in the body that's more set up to take calories throughout the day rather than the evening. So I guess it's just that too, you know.
It's also the interaction between when you eat and what you eat and how much.
Exactly.
When people like me say, "Oh, it's when you eat," that obviously isn't the only thing. We're just emphasizing the fact that timing is important.
Is important, yeah.
But still, what you eat and how much you eat is still also important. It's just that if you also think about the timing, hopefully you'll get an even kind of
better benefit,
extra layer of improvement. But again, it's only fairly recently that we've had the luxury of having, to some degree, as many calories as we want just covered. So if you're living in a situation or a society where perhaps they were eating at funny times of day, but they weren't overeating to the extent that a lot of people do these days. And they were probably doing a lot more physical exercise as well than most of us. So, there are all sorts of counterbalances.
Yeah, there's like, and they're kind of the transient factors I'm talking about in terms of like, you know, like did you eat feck all throughout the day? Were you very active? Was there exercise? You know, so kind of like there's so many confounding variables we could talk about. We'd spend all day. But it's funny because it's a lovely segue you just made for me for the second last question was, have you looked into, or is it an area that you would look into, in that the composition of the meals at certain times of day? Because there is a book I actually have by a guy called Sidney Baker. He's an MD. It's called The Circadian Prescription. It's written like in 2000 or something like that. But he was saying, and again, the book is like, in terms of references, it's pony. Like there's no like you're like, is there any like studies to even like, you know, indirectly, you know, back up what he's saying here? But like his sort of process was that in the morning time, the body was better set up to have protein and fat. And in the evening time, or towards more later in the day, you know, he was saying have more of a carbohydrate. The reason for that for him was, you know, the serotonin, melatonin sort of axis, and that you were setting up more of a melatonin sort of raise, which would help with sleep. But then other people argue like you're more insulin sensitive earlier on in the day, that maybe carbohydrates we had then. And then other people say if you have a load of carbohydrates in the evening, it has an effect then on growth hormone release, and that could be an issue. So there's loads of things like that. But my question to you is there any research around the composition of those meals, not only the timing?
Not a lot is the short answer. And again, it's something which I think people will start to look at more and more. At this stage, because it's still a fairly new research area. Again, in order to make good scientific sense and to interpret the data more easily, people like us, for example, are controlling. So when we give someone a meal at a certain time of day, we make sure that all our meals are isocaloric and have the same balance of carbohydrate, fat, and protein. So otherwise, someone could say, well, is it a mealtime effect or is it a composition effect? And scientifically, you can't answer that question. Once we know that there is a specific time effect, we can then see how does the time effect interact with other things such as
the composition. I mean, the other thing too, though, John, is that like every one of us is so unique in our response to any stimuli. So, like, I mean, there's studies there where they showed like two people taking a banana. One fella has a massive insulin spike, the other fella has nothing, and then the two same people taking a Mars bar or Snickers, and like one had no insulin reaction, the other had a massive one too. Yeah, like how we react and respond to meals from one individual to another is huge, and not only that, but how we ourselves react from a meal from moment to moment. Like you could have, now I'm using the air quotes here for people that can't see, but you could potentially have the same meal in terms of like the calories on the plate and the composition, like, you know, so let's say it was like sweet potato and steak and some broccoli, and you eat that at the same time on a Monday, and you eat that very same meal the next day on Tuesday. But on Tuesday, like, you could have had an argument with someone, you could have slept bad the night before, you could have exercised Tuesday morning, you didn't on Monday. Like, there's so many, again, transient factors that will have you metabolize that meal differently. So even this is the other thing too, when you say like me and you, John, are sitting down to an isocaloric meal, like I'm going to metabolize that meal completely different to how you're going to metabolize that meal as well. So there's just so many like, so basically what I'm saying is everyone is an N of one in and of themselves. So we're never going to get this like golden, like here's the general guideline for, you know, 95% of people in the middle of that bell curve.
How to answer that one? Yeah, I think it's it's a question that relates to anyone doing biomedical research. This idea of
I was just about to say, like, this is where the future's going. Like, this is where like everything's going in terms of like fitness, medicine, nutrition. Like it's all going to go to like trying to individualize as much as possible. So biometrics, you just mentioned the word there, like a huge area going forward is this thing of biofeedback, so people can start to individualize things. Like, I have a good friend, James Fitzgerald, and he said to me, he's the founder of OPEX, which is where this who this podcast is for, OPEX. But James is like, he envisions a future where like you're going to wake up, John, in the morning, like, and like your phone and your fridge and all are going to be talking to you and go, good morning, John, your current hydration status is this. You should ideally consume these foods based on your current chemistry in your body. And it'll just start making like recommendations to you, or whatever. Just, it's going to give you so much biofeedback that you'll be able to more individualize what you need in that current time. Whereas I think like a lot of people are hoping that like research could say like, well, protein in the morning is generally better. It's just like, you can't say that because like everyone's so individual, you know?
Yeah, I mean, it's, again, a lot of research historically and probably still now is what is best for the overall group of people. But yeah, you get some big responders, some small responders, and most people are in the middle, as you said. There is a lot more interest at the moment in actually looking for the kind of distinct outlier populations, so the extreme of one end or another. And if you can understand why people are kind of high responder or a low responder, whatever it might be, that actually might give you some really powerful information about the process of how it works and therefore how it varies between people. So I think people are doing that, and I know, you know, I've heard that there's one of the really senior profs at Cambridge working in metabolism there, and he came out a while ago saying, I don't want to study the population anymore. I want to find specific patient groups, small patient groups, and work out what makes them who they are.
Because I want to deal with the freaks.
Yeah, I don't think he quite said that, but this is basically the idea. If you can work out what they're doing, you might get more information than just looking at kind of Joe Public.
You read between the lines.
Yeah, just a little bit.
My final question here for you regarding our whole topic today is in terms of the environment. So like I just mean like the environment within homes, within buildings, lighting out in the street, just the whole environmental setup and culture. What recommendations would you make, or what changes would you like to see going forward to optimize circadian health for the populace as a whole? So like, just for let you answer that, another area I've been getting into lately is this sort of human-centric lighting. So like lighting within buildings going forward in the future, they're gonna just basically be like the sun. So you're gonna get the full spectrum of light. Because a big thing too with circadian biology, and I've no doubt you've seen this, is like our light diet is the equivalent of a food diet that's a junk food diet. It's like going to KFC or McDonald's every day, because we're just constantly getting only certain light spectrums. So we're not getting that full light spectrum because we're indoors all day. You know, as a species, we developed outside under the sun, and we got that full spectrum all the time. Even when it's a cloudy day, you're still getting far more lux and a far more full spectrum of light. And basically, you're getting a better light diet, if you want to put it that way. Like, you're getting more light nutrients. So going forward in the future, John, like, do you see buildings set up where there's more light going in, more windows, more glass, better lighting structures? The lights out in the street will, they'll be amber more at night rather than like bright. Most of them are amber anyway. But just in terms of going forward, what do you think will happen? What would you like to see to optimize circadian biology and the health of the global population?
Okay, so yeah, light is, I think, unquestionably the most powerful environmental factor that affects certainly human circadian rhythms. So before addressing the question about kind of buildings and offices and stuff like that, in terms of what you might call a healthy lifestyle, I think trying to keep your routine as regular as possible. So
Okay,
your sleep-wake timing is as regular as possible. Obviously, it's not going to be possible every single day to be that rigid, depending on your lifestyle. But the more you can keep yourself the same cycle, better. Getting light, external outdoors light, early in the morning is very important for synchronizing your clock system. You mentioned the strength of light. Yeah, one thing that amazed me when I started looking into this more was that, and any photographer will probably tell you, that if you actually measure the number of lux, which is just a crude measure of light intensity, a bright room might be, say, 200 lux, a dim room might be sort of 40 or 50 lux. If you're outside on a cloudy day, you're already over 1,000. And if you're outside on a really bright sunny day, you're probably over 10,000. So there's a huge difference in what you might consider a bright light in a room versus actually what you're getting even on a cloudy day if you're outside. Yeah. So going outside is important. So direct exposure to the sun, so not through a glass window or the window of your car if possible. Try and get about 15 minutes or so of direct sunlight as early as you can during the day. I think is important. In terms of meal times, trying to keep them as regular as possible. We're still only starting to understand what parts of your circadian system are most regulated by food, but clearly certain parts are. Your glucose metabolism, for example, seems particularly sensitive to timing. That's important. Good sleep hygiene, which is a phrase which sounds a bit bizarre, but it's simple tips you can use to help yourself get to sleep. So don't have caffeine in the evening, or probably not indeed late afternoon for some people. So obviously caffeine is a stimulant that certainly in some people really keeps them awake a lot. Try to avoid light. There's been a lot of press recently about light from computer screens, phones and tablets. And just looking at these things, although a lot of them now, as a result of this work, now have blue light dimmers. Use that, or you can use these blue light blockers. So these things.
I have two pairs as well. I think I have my amber, I'll get them for you now. While we're talking here, they're just in my coat here. I've got two pairs. I have an amber pair for kind of like, oh, there they fell out. Them ones there.
That's the one, yeah. Yeah.
They for kind of like earlier in the day, they're not quite as intense, but then if it gets darker, I got the orange ones as well. So yeah, listen, there's some great applicable concepts people can take away, because I had Amy Bender too on the podcast. She's a sleep researcher in Canada, and she made some very similar recommendations as well. Wrapping up here, John. Again, I just want to say I really appreciate making time today. Like I would say this, I know you're busy, but I actually don't. You could be doing nothing for all I know. But I'm assuming, which is not always good to make assumptions according to the Book 4 agreements, but I'm assuming you're a busy guy. Just a few little quick fire ones if you have some time.
Okay.
What is your current and top reading recommendations? So are you reading any books? And if you are, what is it? And what would your number one book be to give away to people?
Right. I must confess I haven't I haven't read. Dear, I haven't read a book for an awful long time.
Doesn't matter.
Having young kids is not conducive to lots of time for reading. One thing that I did get though for my birthday is P.G. Wodehouse, which I love because it's funny It's
Just say that again, because you kind of broke up. What's the name of the book?
The author P.G. Woodhouse, the guy who did Jeeves and Wooster and all this.
P.G. Woodhouse. Okay.
Yeah. So it's very kind of slightly antiquated, but very gentle, non-offensive kind of humor. It's not one of these comedy things that makes you laugh out loud, but you just kind of read it with a happy little smile on your face.
Yeah, we have an Irish version of that. It's called Ross O'Carroll Kelly. He writes all those books. They're like comedy. Yeah, it's similar. Like it's like he writes books and he's kind of like, he'd be slagging off the posh people in Dublin versus like the gangsters in Dublin and stuff like that. I haven't read them, but it's very popular. Other people read them and they're great.
It's just something nice and relaxing. And in this case, it's a collection of stories about cricket, so I'm a bit of a cricket fan, which I know with the World Cup in Ireland and that, of course, as well. So at least some people in Ireland are into cricket. I'm not sure how many.
We bet Pakistan a few years back.
All right.
At the World Cup, that was a good few years ago. John, how do you learn? What's your learning process? I'm always intrigued about how people learn.
I think I learn most by reading something and thinking about it in my own time. One thing that, hand on heart, I'm not very good at is actually learning stuff audibly. And I think that's why I was never that good at languages. I was much better at formulating sentences when I was learning at school.
Yeah.
But when it came to listening to tape recordings and working out what was being said, I'm not that good at picking up information through my ears and making sense of it. But if I have it in my own time, put it in my own kind of context, for me, that's much more important. So I much prefer reading than listening.
So, John, would you read and then would you make notes on that? Is that how you consolidate knowledge?
Yeah, I think so. I mean, when I read a paper, certainly when I did as a PhD student, when I was having to learn an awful lot more, what I would usually do is I'd read a paper, take me an hour or two, for example, and then just on the front cover, I would just scribble 2 bullet points. What are the 2 key messages? Because that way you can really focus on the salient points and not get too carried away.
Yeah, like
so yeah, I'm a big fan of just making notes, picking 1 or 2 key points, and once they stick, you can then kind of easily flesh that out a little bit.
Sweet. What would you say have been the biggest lessons you have learned so far in your life?
So things that I thought about perhaps 10 or 15, perhaps 20 years ago. I don't know why I started thinking this, but I was thinking about what are the most kind of meaningful things that my parents told me. One of those, which I think is great for anyone, is don't be afraid to ask for help. However good we are, whatever it is we do, no one's perfect. And I think sometimes I think I might see it with some colleagues. Again, I'll be careful to name anybody. But I think if people are used to being right or thinking they're right most of the time, they perhaps find the real difficulty in acknowledging when they don't know something, or when they'll be much better served to ask someone who actually knows something
really good,
better than they do. So I think asking for help is really important. Something else I think one that my dad told me, as most academics, I'm kind of introverted by nature. He says there's a certain age where you can't get away with being shy. So when you're a young kid, you can kind of hide behind a chair or hide behind someone's legs or something, and that's sort of okay up to a point. But once you get to a certain age, that kind of becomes very difficult to justify, and you need to find a way of getting over it.
Yeah.
And in my experience, certainly professionally, if you go up to someone and say, "Hi, this is me," and you basically introduce yourself, I don't know a single person that just kind of look at you and just tell you to get lost. Everyone that I know that I've done that to and I've seen it happen will always at least make a little bit of time to talk. Yeah. I think sometimes the fear of rejection, particularly if you're a little bit shy and introverted, is a really unhealthy thing, because most people are very happy to be friendly. They might not be able to give you that much time, but no one's just going to turn you away, I think.
Yeah. So don't be afraid to ask for help.
Yeah, I think so. Don't feel that you can't talk to people.
Yeah, brilliant. Really, very good. John, you've only 1 year left on planet Earth. Now you're not dying, okay? You're basically, Elon Musk has set up a Starship Enterprise type model And he's like, listen, it's a one-way ticket to the stars, but you're never coming back. Now, your family are coming with you, so they're coming with you, but you're never coming back to planet Earth. How would you spend that last year on planet Earth?
I would probably try and meet as many of my friends as I could. I've got friends living in all sorts of different places, and I think that friendships are the most important things.
Great.
It's a bit of a cliche, but I think it's true. In academia, you're kind of lucky enough that we go to conferences around the world and we meet people. I've got people from all four corners of the world who happen to be living in this system. So I would like to go around and kind of do a bit of a Phileas Fogg thing and actually meet as many of these people as I could.
Yeah, sweet. Sweet, that's great. Very last one for you. I'm taking you for dinner, and you're again, your family are included on this, so they don't count as guests, so they're all coming. But right. I say to you, John, you can invite 5 people to dinner now, and these 5 people can be dead or alive. Who would you bring to this dinner and why?
Do they have to be real people, or could they be fictional?
No, they can be anyone. They can be real, fake, dead, or alive.
When I was a kid, I always wanted to meet Sherlock Holmes.
Yeah.
This is before the kind of recent TV stuff where it's all become a bit fashionable again. But I was always kind of intrigued by someone like that, just to have a little bit of time talking and to try and, well, at least how the recent TV things goes. I wouldn't get very far, but just trying to work out a little bit what makes them tick.
Yeah.
I think Sherlock Holmes would be one.
I think he's the first time someone said him.
All right. Okay.
We've had fictional characters before, like someone wanted Batman, so that's cool. Sherlock Holmes, great.
So I think that would be one. Who the others are, I really don't know. There are a few characters that I've seen, documentaries. I never liked history and things as a kid. I was always into sciences and languages. But now I'm older, and history isn't just a load of boring facts. And when you get into the kind of politics and the personalities, it's fascinating. So potentially all sorts of interesting people from history that you would like to kind of find out a little bit more. People who've really shaped the world, and there are all sorts of historic, I suppose, kings and queens and other people as well. But something else which is it's a huge tangent. There's a character, a cellist. I happened to be watching a documentary, got no idea why, called Rostropovich, who is basically a world famous cellist. I don't think there are that many kind of virtuoso cellists. This is a guy who was kind of his powers, I think, around the 1960s, and later, and he basically would play any kind of music that was written for cello, even if he thought it was complete baloney, simply because he wanted to kind of publicize the cello as a much more interesting instrument than it was. But this guy was completely bonkers. He was Russian because he's living behind the Iron Curtain, but because of his talent, he was one of these people, like a lot of athletes and musicians, who got around the world. Yeah. And one thing that stuck in my mind, which made me think, not only is this guy bonkers, but entertaining, but really interesting, was that he apparently was really big friends with a Japanese sumo wrestler called Chrono-Nutrition, who I only know about because when Channel 4 started in Britain when I was a kid, they had sport from around the world, including things like sumo wrestling, kabaddi from India, Aussie rules, which I loved. I was fascinated by. And Chrono-Nutrition was the kind of big guy at the time. And apparently, I think it's when Chrono-Nutrition's wife or someone had died, this cellist flew from Russia in his own money, took his cello with him, sat outside Chrono-Nutrition's house, and started playing music for him to make him feel better. And it's a slightly bizarre one-off thing, but someone who can do that is that nutty, but also kind of that nice and caring. I think it would be a really, really interesting. So that would be another one. Sherlock Holmes and this mad cellist, I think, would be two.
Just say his name one more time there. The cellist's name.
I think it Rostropovich.
Rostropovich. Well, I'll check it. Because for the show notes, I might have to get you to send these people like links. To these people.
Okay.
So that's 2.
Oh God, you still want the other 3? Okay.
If you can, and again, John, listen, one thing is like I always feel people like they nearly panic a little bit because like, oh, if I don't make my answer really profound here, I'm gonna wish, like, I think a lot of people get in their head this sort of thing, like they'll say 5 people and then later on this evening they'll be like, oh, I should have said him or her instead. So it's just whoever's in the moment,
Yeah.
They're 2 super interesting ones already, though.
Yeah, I think that would be good. If you wanted others, I suppose another group of people that might be interesting are people I knew when I was really young.
Yeah.
I've lost touch with, find out what they've done with their lives. So kind of kids from primary school.
Old friends, yeah, it's cool.
Yeah, just to find out what they're up to. Or people that I have vague memories of. There are people that I remember their names, but I've got no idea what they look like or who they were. So if I ever met them, I wouldn't know them from Adam. But it'd be interesting to find out kind of primary school mates what they're up to. To be honest, I would probably pick a couple of other historical characters. Either someone completely like a kind of Genghis Khan sort of character.
Yeah. Few people have said Genghis Khan. Yeah.
Yeah, that might be a bit dangerous to do that. I'm not sure how long I'd last if that happened. Or someone like that, or someone like Florence Nightingale, or
cool.
Or just someone who has made a huge impact. Martin Luther King, I imagine, is one that's come up a few times.
He's in mine. Like he's in my.
Okay, yeah. I mean, just someone like that who put themselves on the line and to teach you an awful lot, as well as being really interesting.
Yeah, he'd be super interesting bloke, I think. And plus, he's just got such a cool voice, too, hasn't he?
Yeah. Oh, it's amazing.
Such an order. John, listen, that's been fantastic. It's been an absolute pleasure to talk to you. I'll say goodbye to you offline. But before I let you go, if anybody wanted to reach out and contact you, where would be the best place to get you?
Probably find about me on my university email page.
Yeah, I'll put that in the show notes.
Put it on there. And I've got an email address. I mean, one thing that I cannot do is give anyone kind of individual clinical advice, as I'm not a physician.
Yeah.
So I'll kind of say that up front.
Cool.
But yeah, if people want to find out a little bit more about me and what I'm up to, then I keep my university webpage pretty much up to date.
Great. You're on ResearchGate too, are you?
I might be. I don't actively use that. There are so many of these online databases. You spend your whole life. ResearchGate is very good, though, I must say. I think it's pretty good. Yeah, I think it's one that, for whatever reason, I've just not got around to yet.
Yeah. Well, listen, I'll put your university page in the show notes. And that has that's how I actually got your email and contacted you. So I'll put that in. But again, as I said to you, I'll say goodbye to you offline. And one more time, really appreciate taking time. Thanks so much.
Thank you. It's been a pleasure.
Yeah. So, guys, what an absolute pleasure talking to John today. Again, I'll have everything linked up in the show notes. And so if you want to get John's contact details and maybe ask some questions about his research and what he's got going on, you can get the details there. But for now, take care. Peace.